Good afternoon, everyone. Maybe good morning to some of you. Please be welcome to our today's webinar, which will be focused on shot peening for transmission parts. There will be two parts in our today's webinar. First one will be a presentation, and then you will have time for discussion. How to interact with our presenter today? You can check on the right side of your screen. You have a control panel with a chat tab. So you can use this chat tab to ask as many questions as you want. Please be aware that there's only your name on the chat. So you are not identified with your company or any entity or even your surname. So feel free to ask any question you want. And we will try to answer to all these questions during the second step. For the people who could not attend the webinar, we are recording this webinar. So afterwards, you will have a link. You will receive a link through an email. You would be able to download all the contents and also the audio comments of today's presenter. You might have read the presentation when you register on our webpage, but I will introduce you our presenter. So you can see Frédéric, who's specialized for years now in shot peening process. And you can also see Sébastien,
good afternoon,
who is our project manager for the customized machines. Now you might see on the left of your screen the presentation. You can adjust the presentation to a full screen. And so, yes, you can have a full screen or you can leave the chat open to ask your question. I'll be back during the questions and answers. So I will leave the guys speak and I'll let you enjoy the presentation. Bye.
So thank you, Juliette. So we start with the shot peening and innovation for high performance transmission parts. So shot peening application in automotive engineering are very varied and apply to components subject to high cycle stress. So shot peening can be applied on bevel gear, idle gear, output shaft made in steel. We can shot peen also aluminum housing for Formula One, or compressor wheel made in aluminum, or a turbo wheel made in Inconel. So what we observe is that SUV took a record of 38% of the total European new car market in 2019. And electrified cars gain market share. Cars are of necessity lighter, more compact, more durable, as well as being safer and more reliable and comfortable. Any engineer involved with the dynamic components of a car is immediately faced with the design of smaller parts to carry greater loads. So mostly transmission gears are carburized steel and case hardened to 60 HRC, so work well hardness minimum. But after many millions of cycles, tiny cracks at the root tooth or pitting on the flanks can eventually appear, which is the area that carries the greatest loads. And so at shot peening is a method to increase the fatigue strength. So how SONATS investigate with a new application and gear? So first of all, we study the scope of work of the customer, perform tooling development, perform some trial with different recipe, shot peening parameters, and simulation definition. And finally, we perform residual stress profile by XRD to guarantee the consistency of the process. After customer approval, we can perform shot peening at SONATS company, and or we can manufacture and design a specific machine. We are able to perform the commissioning at customer site worldwide, and for any assistance, we can perform a technical support. So what is the shot peening process? So this is the core working impact treatment consisting in shocking a metallic part surface with spherical media, aiming at modifying its surface characteristics. So why use shot peening? So it's to improve the fatigue life and parts reliability and enhances stress corrosion cracking resistance. So I can explain these techniques of ultrasonic shot peening by drawing parallels with conventional shot peening, where energy is transferred from the peening media to the part being peened. Media propulsion in shot peening uses compressor air on the centrifugal force. At SONATS, we refer to USP as a stress-sonic technologies, which uses acceleration, not by the compressor air, but by the acceleration of a vibrating surface called the SONATS rod, which vibrates at 20 kilohertz to propel small sample of shots against the surface to be treated. So the SONATS rod is located at the top of the acoustic set, and most of the case beneath the tooling. So we pour in the media at the surface of the SONATS rod inside the treatment chamber. So we place the output shaft, close the treatment chamber, rotate the part, and thanks to the generator, the acoustic set, and the sensor, we guarantee the vibration and the consistency of the process. So since this takes place in a control and sealed chamber that envelopes the local area to be treated, there is no escape of media. So at the end, we remove the output shaft from the enclosure and we observe the treated area. So this allows the process to use a few grams of high quality media for repeatable peening result. For example, 14 grams of bearing balls can peen 200 parts. On this video, we can see the process of shot peening and the peening configuration. In the plexiglass enclosure, just for demonstration purpose. So this enclosure is an hermetic chamber designed to closely wrap around the contour of the part being peened. So you see the motion of the media, ceramic media. So there is no need of masking or unmasking operations to protect other areas from peening. So usually for industrial application, the enclosure is made in hard steel, and the other components are made in plastic or 3D printing to avoid any scratches on the part.
Excuse me, Fred. Some of our participants are not seeing the videos, so maybe you can try to explain with your words what is running on the video, just for them to see.
The previous one or this one?
Maybe this one, yes.
This one? Okay. So the robot clamp the output shaft in the complete enclosure. The enclosure is made in plexiglass for this application to see the motion of the media inside the treatment chamber. But usually the material of the enclosure is made in hard steel, and the other components are made in 3D printing or plastic to avoid any scratches on the part. So maybe you will see properly the other video. So in this new video, you will see the trajectory of the media. The speed velocity is within the range of 2 up to 10 meters per second. So the key parameters for USP are the media diameter, the material of the media, the amount of media in the enclosure, and the amplitude of vibration. Usually USPs, or ultrasonic shot peening, use the media 1 millimeter or 1.5 millimeter in diameter for gears, to reach an element intensity of 0.20 up to 0.50 mm-A. But we can also use tungsten carbide media because to get a high intensity, because the density of the tungsten carbide media is 2 times higher compared to steel. So element intensity is a method to quantify the intensity of the shot peening process. So what we observe in the curve, for example, the blue one, is that if we increase the amplitude of vibration, we increase the element intensity. If we want to match the customer criteria, we can change the media diameter. So the peening time is also, as conventional, automatically controlled to ensure that the coverage time is accurate. USP complies with standard specifications AMS 2430, G442, G443, G2277. Characteristics or characterization, sorry, as usually performed by X-ray diffraction. So what we observe, if we shot peen at a low peening intensity, we will get probably an affected depth close to 80 micron in depth. And if we increase the peening intensity, we can achieve roughly 200 micron. But of course, depending on the customer specification, we can achieve an affected depth of roughly 300. What we observe that in all cases, for all intensities and material, USP provides smoother surface compared to conventional due to the high quality of media, such as tungsten carbide, ceramic high density steel, perfectly spherical, and thanks to the omnidirectional flow of media, as you observed in the previous video. So USP follows AMS 2585 for the media properties, such as the hardness, sphericity, size distribution, material, and density. And at SONATS, we also perform durability tests on media according to the process specification. And for, of course, each application. One other parameter is that the chamber design, because the chamber design shall not have any features to trap shots or damage the top of the teeth, which result usually in a wallover, which can be detrimental for noise, vibration, and harshness testing. So we develop specific enclosure with mask within the chamber to protect the top of the teeth and focus the flow of media toward the roots and the flanks only. For complex geometry, we have a 3D numerical model of shot motion based on the theory of granular cases. It helps to measure the shot velocity distribution in the chamber, identify impact locations on the pin surface, of course, the coverage rate, optimize the process parameters, and validate the pinning configuration and the design of the enclosure. So the last characterization is to demonstrate the consistency of the process. Usually we pick up a small batch of parts and shot pin 5 parts according to the same recipe and perform XLT diffraction. So what we observe is that the residual stress distributions on the 5 profiles is roughly the same as the uncertainty of the measurement by X-ray diffraction on steel is roughly plus or minus 30 megapascal. And it results in a RA value of 0.4 micron. So X-ray diffraction is a non-destructive testing procedure that uses X-ray to determine the lattice spacing in the material at and just beneath the surface. So to determine the residual stress profile within a material, the surface is electrically polished, so destructive, a few microns at a time, and XRD measurements are taken. So electropolishing is used since it does not induce stresses in the material. And when all these investigations are completed, so the customer performs the fatigue testing at its own laboratory with its own test rigs. And after its approval, so we can design and fabricate the machine. So I let Sebastian continue to present you the advantages of the machines.
Okay, thank you, Fred. Now I'm going to talk about SONATS equipment, in particular how our products allow to use the USP process on the metallic part for the automotive industry, such as gears, shaft, and other small parts, which need to be pinned, aiming to improve their performance. So our company has developed its first customized machine 25 years ago, and the first ones for automotive market in 2012. Since this first experience and some positive feedbacks, USP process can be a real industrial solution for shot peening operations. So I hope you see the video. So on this short video, you can see a complete installation delivered in 2017 in German market. So on this example, the automatic loading is done with the gantry. This last system takes the output shaft into a basket management device. But we can also imagine to use a 6-axis robot for handling or for a small production batch manual loading by the operator or using the front door of the machine. Then full automatic cycle starts in any available workstation for an USP operation. On the expected area, teeth of the output shaft, in this case, like seen. Okay. So as already said by Frederic, this operation is done without any masking operation. So indeed, a specific enclosure has been designed and made for each reference. So after this operation, the pinning part goes outside the machine using the gantry. More often, the pinning operation is the final one, and the parts can be stored in basket or in their final packaging box. So one of the main advantages of this process is its footprint and its easy implementation in your workshop. Compared to the CSP, the conventional shot peening process, its integration doesn't need any specific building engineering. So you put an USP machine like you will do for CNC machine tools. For example, the machine saw in the previous video got a small dimension equal to 6 square meters, excluded the automatic and loader and basket management devices. So a 4-station machine can produce up to 500,000 parts per year, or take time nearly equal to 30 seconds. So this yearly capacity can be scalable according to your production ramp-up and the quantity of reference you want to pin. So each workstation can accept a large diversity of parts within a range of specific toolings and can produce a total of 125,000 parts per year. So according to the partial geometry and the customer requirements. So USP process has numerous advantages in production. First, it's a clean shot peening process which generates a small quantity of dust. So according to an initial risk analysis, our engineers validate or modify the design of the machine, aiming to control and avoid any latex risks. Often, our customers are afraid about the noise pollution of the ultrasonic frequency generated by the Ultrasonic process. But don't worry, our equipments are in conformity and respect the limitation of the standard. All delivered machine doesn't exceed 75 decibels. USB machine has another positive advantage, a low media consumption. If we take the previous example with a 4-station machine, only 22 kilograms are used for pinning for the 125,000 ports in a full year. So it's data for one station. So a low energy consumption is a positive effect as well. If I take the previous example of the 4-station machine, we can roughly estimate about 1 kilowatt per hour and 12 cubic meter per hour for the compressed air used for the cooling for one machine. So USB machine can be fully automatized. Parts and media handling. In this case, only 30 minutes per shift is necessary for the operator presence. This time for quality control, media filling in the main tank, etc. and so on. And less than 10 minutes for a tooling change. So a reminder, the tool change allows to adapt a specific enclosure for pinning any reference. Each station can treat a different reference or be used for element test, for example. So we can also suggest to you a specific design to integrate an automatic tool change according to your specification if needed. After some customized machine made or delivered for high capacity production line, we detected an opportunity to improve our offer. So we decided to develop a new product range. In 2020, we've developed a new standard based on our own experience, aiming to be suitable to the customer expectation, in particular for automotive industry. Indeed, this market wanted to get a flexible, upgradable, and reliable solution. Therefore, we have designed a modular machine family using different standard modules, which allow to adapt a customized configuration according to the initial client need. So we then suggest a main control cabinet with a quantity of workstation according to the capacity need, up to 120,000 ports per year, and other specific station, such as automatic media handling or quality control station, for example. We consider an average lead time of 5 months between the purchase order receipt to the factory acceptance. So you can also gradually upgrade your machine after delivery. So more likely to be able to increase your production capacity up to 6 stations, or even to add any additional option like automatic handling system or an additional media management station if you need. And so this flexibility has another positive effect because the customer can distribute its investment and limit the associated financial risk over the years. So beyond the scalable capacity of this new machine family, this equipment is more flexible than the previous ones. Each station can be suitable to your workshop configuration. So, for example, be located online, as previous example, but also be put in any position as a single station, as illustrated on this view. So this last solution can be the best way for a 6-axis robot handling. We suggest to you some other options, like a retractable tooling plate to ease the handling operation for tooling change. And then you get a faster and more economic station for the user. So now, Fred.
So here is a sum up of what we as described during this presentation. So the ultrasonic shot peening process is already deployed in the automotive industry because of our experience of automotive markets, our process development ability, our capacity to measure by X-ray diffraction the affected depth by the shot peening, and of course the capacity of the machine to be integrable in a production line at customer plant.
Our team member Cedric has spoken to some of you, and he gave me some questions to ask Fred and Seth. So we're back on video with the guys. So first question I have from Corentin. Are there any size limitation for the parts to be treated? Maybe Fred can answer.
So main gears can be shot peened by ultrasonic shot peening, except where the radius at the root tooth is below 0.3. But for the other application, we are able to shot peen all the gears.
So maybe I think Cedric already gave an answer, but I think the questions are connected. Is it possible to mask some areas of treated parts? So we already said that the specific enclosure is dedicated to enclose the media, but also the treated part, the treated
Yes,
area.
correct.
Anything to
No.
add on? It's a good answer, Cedric. Dan is asking, how do you control shot peening operation?
So ultrasonic shot peening process complies with the all shot peening properties and specification. So we use exactly the same method, so the Allman intensity, X-ray diffraction, to be able to duplicate the same result as conventional.
Okay, so you mentioned conventional.
From a technical point of view now?
Yes.
Probably. Yes, from a technical point of view, if we control the shot peening effect in the on the machine, if we control the amplitude deviation, the mass of balls, and the time of treatment time, the peening operation. So this you shown the different main parameter important for the process. So in a production line, we also control every these parameters to be sure that the whole parts print are in conformity to the customer requirements.
And in this case, when you have a diversity of parts, depending on the station, you can control differently any station?
Yep. The machine save the different parameters according to the reference treating each station.
Okay. So maybe it's also linked, but so we talk about the conventional shot peening. Corentin is asking if I do conventional shot peening now, how can I switch to US shot peening?
We use exactly the same method. We perform some recipe, perform some shot peening according to this recipe, perform X-ray diffraction, and if these results are approved by the customer, we can easily move from conventional to USP. Of course, the customer has to change the machine, but the result will be exactly the same.
So you can duplicate.
We can duplicate exactly the same profile or Allman intensity, but with a better consistency, thanks to the control of the vibration of the amplitude. So we count and measure the media prior and after pinning. We guarantee that the test has been performed properly, the exposure time. All the key parameters are controlled by the machine.
Okay, and with the same recipe, you said between conventional and US shot pinning, with same residual stress profile, you can still have some difference concerning the surface finish?
Usually the surface finish is smoother compared to conventional, and it could be a benefit from some application on gears, usually on the flanks. This is an additional advantage of the USP compared to other solution.
Okay. Feel free to ask other question. I'm going on with the one that are on the chat. We have the question about the price. So maybe Sebastian can answer. The question is, how much does the machine cost? Maybe as every machine is different, we can explain how we define the budget of the machine.
Yes, it's clearly depend the kind of application. Each application is different, so the main parameters to define the price is the cost, is the capacity of the machine. So depending the capacity needed by the customer, we select a quantity of workstation, automatized and complex solution. So the price is defined by the capacity and by the other option like handling system for the part, for the media, etc. But we can also consider the price for the geometry of the part. So the cinematic, which if we need a rotation for pinning or any other automatic cycle, which if je cherche, sorry. So the main way to stop. Je sais pas, cherche mes mots.
It's okay. So it depends on the if you have a static treatment, if you have a dynamic treatment, yeah. And
the quantity of parts pinned at the same time. So if we can also pin one or two or three parts in the same time, and in this case, the tooling is more complex, and then the cost can be more expensive.
I think you are able to provide a cost per part more than a machine, because you include the air, the electricity, the consumables, and so on.
Yeah.
Okay, we have a question from Emilio. He's asking. Oh, first one is yes. Is ultrasonic shot pinning suitable for hardened plastics like ABS?
Unfortunately, we didn't have a lot of experience on such application, but our company will be happy to move forward with this new solution on this material.
Do you mean that you will be glad to receive some samples?
Yes, sure.
So Emilio will talk later then to have a look at ABS. He had another question. Is there a way to predict the surface damage and the parameter limits?
We currently investigate with our CKL 3D model to optimize our process and to be able at the end to identify what is the better solution to get finally the coverage, the element intensity, and the residual stress profile. So this is the next step for SONAT.
Okay, let me check if I missed something. Yes, Romali. Romali question: is it possible to quantify the strain energy density impacted to the parts by this process?
Thanks to the 3D model, yes, we can. But I don't know exactly what she exactly want to answer. Is it possible? Yes, it's possible.
Maybe it's how?
It's how, thanks to the 3D model and the development of this model.
Okay. So maybe in this case, it would be interesting to speak about a dedicated application to maybe, yeah.
Yeah, it is.
Okay, so is there any other question? Yeah, Zuo. Which part would be which part which part is suitable to be done in to be treated in shot peening for electrical vehicle cars? Maybe gears or other parts?
Today, our customer requests the pinning on gears and some other parts, but because of NDA, I cannot spread too many information during this webinar.
Okay. Maybe the differential parts too?
They are smaller and lighter.
Yeah.
Okay, but I cannot tell you more.
Yeah, I think it's related to the when you spoke about the minimum radius we can treat. So I suppose it's mainly the gears up to the smaller dimension.
It could be aluminum casing.
Yeah.
And some other parts.
Maybe the surface finish is more important in electrical vehicle for the noise.
For noise vibration and harshness, of course, yes, but it could be also for local pinning only and not the complete surface of aluminum casing, for example.
Okay, so I think we answer all the question. Maybe we'll wait 2 minutes more to see if some other question come. Maybe you guys have something more to say, I don't know.
No.
So as mentioned before, you will all receive a link afterwards so that you can download. Oh, so you can download the presentation. You will be able to see the videos that some of you have not been able to watch during the presentation. Sorry for that. You will also have a direct contact to the guys, to the team. So we will be able to go forward. I would be glad to. We will be glad to receive feedback from you about this webinar. If you want to know more, any feedback would be appreciated. And we have more questions. Maybe last one. Andreas is asking, is it possible to use this procedure for parts of the steering system? Maybe Fred can answer.
Yes, we perform some fatting testing investigation in the past, which conduct to get a very good result because we can avoid any deformation on, for example, steering racks. So induces compressive stresses and in parallel do not damage the surface and do not produce a arc height of the part.
I've got sorry, another question, Emilio. For materials that are not in your test data bank we mentioned earlier for the ABS, can you perform a feasibility assessment?
Yes, of course. We usually perform feasibility on different applications, different material according to the customer requirement. We can optimize the process and of course share all the investigation and the result with the customer. This is usually how we proceed.
Okay. Is there any other question or precision? Well, I think we've done with the discussion. Many thanks to everyone for the question. We had a few subjects to talk about, so that's very interesting. As I mentioned, you will get the link. I will not repeat, but we will send it to you. Thanks, everyone. And we will see you on the replay video. Thanks, guys.
Thanks. Bye-bye.
Bye.